This is lesson 8-4. We're going to be talking about integers and the coordinate plane. Here's the launch problem.
Write the missing coordinates for points A, B, and C. Explain how you know you are right.
Here is the answer for the launch problem. A is at -3, 2. B is at 3, -2. And C is at -3, -2. You can pause and read this explanation to see how we got those answers. Here's the key concept.
You can have a horizontal number line, and you can have a vertical number line. Together, the two number lines form a coordinate plane. The horizontal number line is called the x-axis. The vertical number line is called the y-axis. The point where the two number lines intersect is the origin. The axes divide the coordinate plane into 4 regions, called quadrants. The quadrants are named in a counterclockwise direction. The region above the x-axis and to the right of the y-axis is quadrant 1. The region above the x-axis and to the left of the y-axis is quadrant 2. The region below the x-axis and to the left of the y-axis is quadrant 3. The region below the x-axis and to the right of the y-axis is quadrant 4. The points on the axes do not lie in any of the quadrants. Just like you can locate points on a number line, you can locate points in the coordinate plane. An ordered pair is a pair of numbers that describe the location of a point in the coordinate plane. The x-coordinate tells the position along the x-axis. The y-coordinate tells the position along the y-axis.
So again, this number line that goes horizontally is the x-axis, which is the first number. This number line that goes vertically is the y-axis, which is the second number. Moving on to part 1.
You can graph points if you know their coordinates. Look at the coordinates x, y. The x-coordinate tells you how far to move right or left from the origin. When the x-coordinate is positive, move right from the origin. When the x-coordinate is negative, move left from the origin. The y-coordinate tells you how far to move up or down from the x-axis. When the y-coordinate is positive, move up from the x-axis. When the y-coordinate is negative, move down from the x-axis. Graph the point A, -2, +1. Start at the origin. The x-coordinate is -2. Move 2 units to the left from the origin. The y-coordinate is +1. Move 1 unit up from the x-axis.
To determine where these coordinates go on our coordinate plane, review what we just talked about in that video, in the key concept, and also the intro to part 1. If I'm trying to graph point A, I want 3, 4. 3 is my x-coordinate, and so 3 is the first number that I want to find on my horizontal number line. If I find 3, I notice that my numbers are counting by 2s, but that doesn't mean that 3 doesn't exist. That just means 3 is simply in between 2 and 4. So if 3 is right here on my number line, I have successfully found my x-coordinate. My second number is 4, and 4 is going to be on my y-axis because it's my second number, and I want to move up to 4, and I would place my dot right at 3, 4. I can then graph B, which is -8, 4. -8, 4, -8 is my first number, so it goes on my x-axis. So I find negative 8, negative 8, negative 8, negative 8. It's right there. Then I want to find negative 4 on my y-axis, staying at negative 8 though. So negative 4 is going down, which leads negative 8, negative 4 at that point right there. Negative 6, 5. So find my negative 6 on my x-axis. It's my first number. And then 5 on my y-axis. Positive numbers are going up. Negative 6, 5 is at this point right here. 1, negative 7. I got to find 1 first on my x-axis. And then I got to go down to negative 7 on my y-axis. There's point 1, negative 7. Last but not least is 0, 2. I need to find 0 on my x-axis. So 0 is right in the middle. Then I need to go up 2. This one is going to be right on the line. 0, 2. So here's the got it problem. Which point is located at 3, negative 2? D is located at 3, negative 2. Find that first number on our x-axis. So here's 1, here's 2, it's labeled 3, and then you go down 2. So 3, negative 2 is point D. Moving on to part 2.
I am X. He's Y.
We're an ordered pair.
Wherever I go,
I'm always there.
when I'm greater than 0,
And so am I.
to quadrant 1,
You'll see us fly.
when I'm less than 0,
But I'm more.
in quadrant 2,
You'll find our door.
when I'm less than 0,
And same for me.
off we go,
To quadrant 3.
when I am greater than 0,
But I am not.
to quadrant 4,
We quickly trot.
I am X. He's Y.
We're an ordered pair.
Wherever I go,
I'm always there.
So as the video was playing, I started writing in positive signs and negative signs to show you without using inequalities. So quadrant one is going to be 2 positive numbers. I can't say that word. Quadrant 2 is going to be a negative X and a positive Y. Quadrant 3 is going to be 2 negative numbers. And quadrant 4 is going to be a positive and then a negative number. Here we want to drag each point to the quadrant it lies in. You're going to guess it first, and then I will put it in the correct square. So negative 3, 4. It belongs in quadrant 2. 3, 5. That one belongs in quadrant 1. 2, negative 5. That one belongs in quadrant 4. Negative 1, negative 3. 2 negatives goes in quadrant 3. Negative 5, negative 5, 2. This one goes in quadrant 2. 2, 1 goes in quadrant 1. Negative 4, negative 4. This goes in quadrant 3. 1, negative 2. Quadrant 4. 2, negative 5 goes in quadrant 2. And 4, negative 1 That one goes into quadrant 4. A trick that helps me is to write in these little faces, is what sometimes students tell me they look like. 2 positive numbers goes in quadrant 1 over here. A negative and a positive goes into quadrant 2. 2 negatives goes into quadrant 3. And then first a positive and then a negative, that one goes into quadrant 4. And as you can see, all of these numbers match my positive and negative signs that I wrote in below them.
In which quadrant is the point -4, 4 located?
It is located in quadrant 2. Part 3, we're going to talk about transformations, so reflections across the x-axis and reflections across the y-axis.
A transformation of a figure is a change in its position, shape, or size. The new figure is the image of the original figure. A reflection is a type of transformation that flips a figure across a line called the line of reflection. A line of reflection acts like a mirror. Reflecting across the x-axis makes a mirror copy of the original figure on the other side of the x-axis. The coordinates of the original figure are 1, 1. The coordinates of the image are 1, -1. The coordinates of the original figure are 2, 1. The coordinates of the image are 2, -1. The coordinates of the original figure are 2, 2. The coordinates of the image are 2, -2.
You can read this if you'd like by pausing the video, but I am going to move on to a reflection across the y-axis.
Reflecting across the y-axis makes a mirror copy of the original figure on the other side of the y-axis. The coordinates of the original figure are 1, 1. The coordinates of the image are -1, 1. The coordinates of the original figure are 2, 1. The coordinates of the image are -2, 1. The coordinates of the original figure are 2, 2. The coordinates of the image are -2, 2.
So when you have a reflection across the y-axis, your x-coordinate is the number that changes. When you have a reflection across the x-axis, which was the first example, your y-coordinate changes, so the second number changes. I want you to try and complete each of these statements first. I know it might be difficult. I will give you the answers in a second. Here we have the answers filled in. The reflections across the x-axis means my y-coordinate is going to be the opposite number. So -2 and 2 are my opposite numbers. Down here, -3 and 3 are my opposite numbers. My x-coordinate stays the same. When I'm reflecting across the y-axis, I changed my first coordinate to the opposite. So -3 and 3, 2 and -2, they're both opposites. My y-coordinate stays the same.
What is the reflection of 3, 4 across the y-axis?
The correct answer is -3, 4. Crossing the y-axis, my x-coordinate changes. So -3 and 3 are my opposite numbers. 4 stays the same. That's all for lesson 8-4.